Okay, welcome back. And for our last video for the week on Divide and Conquer, we have what we call the Master Theorem. So before we talk about it, we talk about the Master Theorem. So it will be useful for us to notice na yung recurrence relation, if we have a divide and conquer algorithm, can be simplified or generalized as this form. So, yung T of n natin is equal to A times T of n over B plus a function in terms of n. So, function, itong f of n natin, it describes yung running time ng merge operation. Yung B, it's the number of partitions we make, and A describes the number of partitions we actually operate on or conquer. So recall for binary search, f of n is a constant since yung merging natin, or I guess anything else dun sa ating function for binary search is just a constant operation. So lahat ng parts ng function natin dito, lahat naman sila is constant type. So, ayan, f of n binary sort ay just a constant, ay binary search ay just constant. And then, yung B or yung partitions natin is 2 since we partition our list by 2. And then, ang A for binary search ay 1 since only one partition yung sinesearch natin. Then, in contrast, sa merge sort and yung ating maximum subarray, yung f of n natin is linear because of the additional function na merge. And yung ating B is 2 since hinahati natin siya into two partitions. And then both partitions are sorted, so yung A natin is also 2. So yan, depending on these coefficients, A, B, at saka f of n, the master theorem tells us that the following can be said about the time complexity of our divide and conquer algorithms, assuming that yung base case natin ay constant yung running time. So, which is most divide and conquer algorithms naman. So, usually yung base case is a trivial na our base case has a trivial na solution. So, ayan, if ang ating big O ni f of n or yung complexity ng merge operation is less than n to the log base b of a, then theta of p of n is n to the log b of a. So yung theta notation just means that the upper bound or lower bound is the same sa ating complexity. So recall na yung upper bound siya yung big O, lower bound is yung best case or yung omega. So pagka pareho yung upper bound and lower bound, which means that kahit anong input is approximately, ito na yung running time niya, so theta. So, ayan. So, for our divide and conquer algorithms, ito yung theta niya. If f of n is equal to n, so if yung complexity ng f of n equal siya sa n to the log b of a, then our theta of p of n is n log to the n log base b of a times log n. Then if f of n is bigger or is of higher complexity than n to the log b of a, then yung time complexity is yung time complexity ng merge or ng f of n. So for example, ay nga pag binary search, B search, we have p of n equals 1 times p of n over 2 plus O of 1. So comparing f of n, so which is O of 1, and yung log n to the log base b. So b is 2, n to the log 2 of A, log base 2 of 1. So this one means log base 2 of 1. So ano yung power ni 2 para maging 1? That is 0. And n to the 0 is 1. So O of 1 is equal to 1. Therefore, yung ating complexity is n log b to the a times log n. So Cn log b to the a is 1. So the time complexity natin is log of n. So actually, yung nakalagay dito sa baba. So, ayan, this is consistent with what we arrived with kanina. And then, for ano naman, for merge sort, since we have p of n is equal to 2 times p of n over 2 plus of n. So we compare of n to n log 2 to the of 2, basically. So what we get here is log base 2 of 2. This is equal to n to the 1. And we again get equal. And then since this term is equal to, this is equal to n, our time complexity is n log n, which is consistent din sa ating examples. So, ayun, medyo wala tayong variety. Lahat sila of the second case. But for example, if you get something na yung big O natin dito was, for example, a constant, when we compare it, we compare O of 1 to n log base 2 of 2, which is n, which is greater. So yung time complexity nito is yung first case na n to the log b of a, which is big O. Then, anyone, if yung other example, if this was, for example, 3 times b of n over 2, actually, let's say this was p of n over 2 plus O of n squared. When we compare yung ating f of n, O of n squared, we compare it with n to the log b of n log base ba. So log base 2 of 1 for this example. So yung ating right-hand expression is n to the 0, which is equal to 1. So this is obviously greater than n squared. So this one simplifies to big O of n squared. So you can think of this n to the log b of a as the number of recursive function calls. So if mas madami yung recursive function calls natin doon sa merge operation, siya yung may dominant na time consumption ng ating maging dominant term ng ating time complexity. So basically, this just compares yung number of recursive calls doon sa ating merge operation. If mas malaki yung merge operation, mas malaki yung time complexity ng merge operation, siya yung dominant. Otherwise, yung number of recursive calls, siya yung dominant. Or if pareho sila, it's the number of recursive calls times log of n. So ayun, this should help simplify or mapapadali nyo dapat yung inyong pag-analyze ng time complexity ng divide and conquer functions. So that is all for the week. And yeah, good luck with your assessment.